These questions are a lot like the ones that we did on Friday and previously when we did applications, except I think the two that are here are decay. So we're using this formula where you're subtracting. So setting it up is the first part that we have to do it. All these questions on the test that we have on Thursday on this, you're always required to write out the variables, create the equation. Remember, we did a learning goal, and a lot of people jumped straight to using the equation, but I want to actually see the equation first. Then you sub in to use the equation and solve for whatever you're solving for. And there's a couple of different things that you can kind of solve for. Okay, so, and you will have to determine if it's growing or decaying for the test kind of thing. So californium 253, that's an isotope of the element californium. That's why they always have those numbers. You don't really need to know that, but that's what that means. A radioactive isotope has a half-life of about 17 days. And half-life is a specific type of these applications, right? So if there's a 36 milligram sample now, when will there be 1.125 milligrams remaining? So A equals A naught, R, T, and N. The 36 milligram sample is now, so the 36 goes here, and we want to find out how long until we get the end amount, 1.125. If you got those backwards, your answer is going to end up being really strange. So make sure you think about that when you're doing it and get them in the right place. Sometimes the bigger number goes first, sometimes it goes second, and that depends on if it's growing or decaying, right? But you got to get that right. Half-life, and some people make this mistake, but half-life, you got to know that the rate is a half, or 0.5. Okay, that's super important. That's the whole point of the half-life thing. Time is what we're looking for, and N is how long it takes for the growth or decay to occur. So it's happening every 17 days. So that's 17. Then we write the equation, and remember we write the equation before subbing in. So A equals 36 times 1 minus 0.5, or because it's half-life, you can just put 0.5 in there to the T over 17. So that's writing out the equation, and then I sub in, and in this case, like I said, we're solving for time. Times 0.5 to the T over 17. What's always the first step when we're solving for the exponent?
Divide the A value by the A naught.
Yeah, very good. Divide, in this case, by 36 on both sides. Every single time, that's what we start with. Need our calculator for that. So that gives 0.03125 equals 0.5 to the T over 17. And now watch carefully. This is again what we have to know, that I'm writing both sides with a base of 0.5. So this has to be 0.5 to the something equals 0.5 to the T over 17. So I have to guess and check to figure out what goes in that box, 0.5 to some exponent, to give me that number. Anybody have a guess? 5? So if you don't, and it's literally guess and checking, there's not any way to know unless we've already done it. And that was correct. So it's 5 to the 5. Then we say, therefore, T over 17 equals 5. The exponents have to be the same. Multiply both sides by 17, and T is 85. Therefore, and it was a half-life of 17 days, it will take 85 days for it to decay to that amount. All right, try one more. This is an interesting one. As grandma ages, her height is decreasing by 0.2% per year. If she's 150 centimeters tall now, how long until she is about 147 centimeters? Okay, so same thing, her height is decreasing. When you read the question, you gotta take a moment to think about, is it growing or decreasing? The ones that we're looking at today are decay, but they will eventually get all mixed together. So the final amount will be the small amount, and the starting amount is she starts at 150 centimeters. Be careful of this. Because this is already a decimal, some people say the rate is 0.2, but it's actually 0.2 divided by 100. It's given as a percentage, so you got to divide by 100. Use your calculator, 0.2 divided by 100, and you get 0.002. And it's per 1 year, so n is 1. One minus 0.02 to the t. Same first step, divide both sides by 150. 147 divided by 150 gives me 0.98. And that is exact, that's not rounded, and you wouldn't want to round that. You'd want to keep it the way it is. Yeah. Yeah, sorry, I'm missing a 0 there. Thank you. And then same thing, I've got to do 0.998 to some exponent equals 0.998 to the t. And we just have to randomly guess and check. So I'm going to start with 0.998 to the 5. And that gave me 0.990. You might, when it's decimals and like kind of messy like this, you probably will find it a little bit tricky to even know, like, do I go bigger or smaller? So just try. You just got to try a bunch of different things on your calculator until you start getting close, and then you can kind of figure it out. Yeah. No, it's 0.998 because there's 002. What do you mean this? Okay, but that's what this is where we're trying to find out what exponent I put on this number, right, to turn it into the other one. Yes. And again, it's kind of confusing because it's all the 9/8. Okay, and the next one I'm going to try 10. 0.998 to the 10. And I actually get really close. So this was the rule, 0.980, which is what we want. We wanted to turn it into that. But the rule is, I want you to write that one down. Then I want you to write down the one just before it and the one just after it. This is part of our solution to double check that the number we're looking for is between those two. So 0.998 to the 9 is 0.982. And to the 11 is 0.978. So definitely that one's the closest.
If you do it to the 6, it's 0.988.
Right. So that's for, oh, but we want it to be 0.98. This is like 0.980 kind of thing, right? That's what we want it to equal. So when I look at this list, it's 0.982, 0.980, 0.978. This one's the closest to that number because that's like 0.980. So we want 10. And then that's it. Therefore, t equals 10. Therefore, it'll take 10 years for grandma to shrink 3 centimeters.